Okay, we're now starting video 2. This is 9.2, part 2. We're going to go ahead and construct our confidence interval for population mean, meaning we're going to estimate the population mean using the sample mean that we obtained earlier. Here's the sets of values. And so with this here, we have our point estimate, which we got earlier in the previous example. I want to say it's 30, let's go back at 36.8. And so we're trying to come up with an estimate of the miles per gallon a Ford Focus 2011 would have. And so we have a point estimate, 36.8, but we want to go ahead now and see what an interval estimate would look like, or a confidence interval, where we're 95% confident about that. So to construct a confidence interval, we need to know all of these values here, right? And the confidence interval is the lower bound and the upper bound, which we have these formulas here to do that. And so I'd like to just list the information that we have. So we have this information right here. So let's go ahead and work with what we have. So the first thing we know is we're doing a 95% confidence interval, which means our alpha is 0.05. That will then lead us to calculate what's called the t critical value, which again from our formula, remember our formula for confidence interval is the point estimate plus or minus the t alpha over 2 times s over square root of n. And so each of these, again, looking at this, this is that's the point. That's the point estimate. That's called your point estimate. This here is called the critical t value. That's your standard deviation and your square root of n. And if you recall from a previous lesson, that is what we call the standard error. So those are the values we need to construct a confidence interval. Let's go ahead and do that. Critical value in this case, t. How many? And our n here is n equals 16. Our degrees of freedom, it's called your df. We right here, df equals n minus 1 degrees of freedom, so that would be equal to 15, because we need that to calculate the t critical. And so to get the t critical, you go to stat crunch. It was 15 again, and 0.05 would go here. And so 1.753 would be our critical value that we're calculating here. And so that would be the t critical. Oh, you know what? Let's do that again. It's not 1.735 because the t critical is alpha over 2. And so in this case, since alpha equals 0.05, alpha divided by 2 is 0.025. And so that's the value I need to put here. That's a mistake a lot of students make. I just made it. It's 2.13. 2.131 we could put in there for the critical value. 2.131. This is the t alpha over 2. And so this is that value we would use there. That would go here. The standard error is standard deviation divided by square root of n. In this case here, the standard deviation for this here, oh, we need to calculate that, so I need time to do that real quick. We only did the mean earlier. The x bar was 36.8, and so I can do that quickly off camera. The standard deviation for this one here is going to be 2.92. And so to calculate the standard error, that would be 2.92 divided by the square root of 16. And so the standard error in this case has a value of, that becomes 0.73, and your margin of error is this value right here, which can also be done in one step. There's your margin of error. And so when you calculate this margin of error, you end up with 2.131 times 0.73 is your margin of error. And so in that case, we should end up with times 2.131, you end up with 1.56. There you go, 1.56. So then your lower bound is going to be 36.8 minus 1.56. Upper bound is going to be 36.8 plus 1.56. And your confidence interval is going to be from two values here. And so you would end up adding those values here. So then your lower bound should be 35.24. Or let me calculate those again. So you have 36.8 minus 1.56. Do that again, 36.8 minus 1.56. Can't use a calculator. 36.8 minus 1.56 equals 35.24. And then the upper bound should then be 38.36. So our confidence interval, we estimate, and we're 95% confident that if you had a Ford Focus, the miles per gallon you would get for that car would be between 35.24 and 38.36. So there's our confidence interval for a sample for a population mean, and there's our estimate. I think we need to try that again. I listed all the things that we need to get that, but of course I think things could start off with something like this here. So let's try this one more time. Construct a 99% confidence interval about the population mean weight of pennies minted in 1982. Assume S equals 0.02 grams. And so to do that, the first thing we need to do is, we know what the standard deviation is. The thing we would need to do is construct, or let's go ahead and write the formula down. X bar plus or minus the T alpha over 2 times S over square root of N. And so that would be our first move that we need to do. Now we have the formula. Let's go ahead and get the values. We know S is equal to 0.02. N is equal to 2, 4, 6, 8, 10, 12, 14, 16, 15, which means the degrees of freedom will be 14. Alpha in this case is 0.01. And so then we also then know that alpha over 2 is 0.005. We're going to need that value in the T calculator. The thing that we're missing is the X bar, so let me calculate that real quick. And so I found the X bar for that. It is 2.46. 2, 4, 6, 8, 10, 12, 16. Oh, this is actually 17. This mean is 17. Let's fix that real quick. I just counted 17. That's 17. Degrees of freedom would be 16. So make that correction. And after doing the calculation, X bar is 2.46. Now with all of these values in hand, equation in hand, we can go ahead and calculate upper bound and lower bound. And so in these cases, then it just becomes the lower bound, I'm going to abbreviate, is going to be 2.46 minus T alpha over 2. Oh, no, we need that value here, so let's do that on the side, the critical value. T alpha over 2 in this case is going to be, we're going to use 0.005, degrees of freedom 16. So we go here, degrees of freedom 16, because it's n minus 1, 0.005, compute. So we're going to use 2.92 as our value. 2.92. So this becomes 2.92 times s, 0.02, all over the square root of 17. And so that will have a value. Your upper bound is going to be 2.46 plus 2.92, 0.02 all over square root of 17. And that's going to have a value. Punch that stuff in the calculator, see what you get. If you do the calculations, you should get 2.448 is the lower bound, upper bound 2.472. And so then your confidence interval, or we assume the weight of a penny is going, I'm 99% confidence the weight of a penny is between 2.448 and 2.472 grams. So I'm confident that I'm 99% confident that's the weight is between those two values. And so that's us doing it by hand. Of course, we can check this on StatCrunch if we plug some numbers in, given some data, and you have the instructions here to construct that. If you have the data or if you have the summary data, for example, I know I have 2.46 and 0.02. So let's take a look at that real quick. You would go here, T-stats, one sample, summary data, and in this case the sample mean was 2.46, standard deviation was 0.02, sample size 17. You'd click a confidence interval 99, compute, and then you get the 2.45 to 2.48 sample mean. And we're off a little because of rounding. 2.472, 2 point. So we're off by rounding because we rounded off, but you can see that's the way you would get a confidence interval using StatCrunch. And so the instructions are there. Okay, we have one more video. That'll be video 3 with sample size. That'll be next.